You wouldn't want to blow up your own boat. So, here's what we got. We got that. We got that. These are fragments. Number one. So, that, and I guess that's kind of slow for something blowing up, but that's what I got. Shush it. The problem will work just fine. And I'll just call it P. So, we done did get something blows up real good into 3 parts. And I won't, give you something more realistic and have it blow up into several hundred for reasons I shouldn't need to explain. Do I need the mass? Well, if it asks for the velocity, I will need the mass. If it asks for the mass, I will need the velocity. But if I just ask for the momentum, that's the product of mass and velocity. So I just want to know the momentum of the third piece, yeah. That's fine. It's okay to think, people, right? Instead of just being like a note-taking zombie. Is this so easy to just sit there and go, because some kids love that. I don't have to think. I just want to copy notes. Okay, so what's going on? You don't really need this question. You know everything you need to solve it. Okay? Do the same thing. Conservation of momentum. So px before, just in the x direction, this isn't all x's and y's, so we got to use components, maybe, is momentum after in the x direction. So, how much momentum did this thing have before? Correct. Because it wasn't moving. This is before it did blow up. After, what's going on? Well, this guy has an x component, has a y component. Okay? So does this one, which I don't know. So I'm going to call that px, because I don't know what it is. Oh, I guess we need an angle here, don't we? That's 60 degrees. So after, I have this guy, which is, I want momentum vector. I need a mass. Do I want it in grams? No. So that's 0.212 times this component of this velocity. And the x component is the cosine. So 9 times cos 60. And actually, I'll probably needs a bit more room there. Okay? Now, careful, because what direction is that in? Yeah, and conventionally, I mean, you can take left as positive, but at least my brain would probably want to make this as easy as possible. And I know that's the positive x direction, so that means that thing is negative. Okay? So make it negative, because it's going the opposite direction as the positive direction. What else do I have in the x direction after? I have this fragment. It has momentum 0.168 times 15. It's in the x direction, so I don't need a component. Or if you like, you do cosine of 0, which is just 1. But why would you? Finally, I got this one. What direction is that in? Yeah, so you can go plus minus, or just put a minus there. That's px. That's what I don't know. Okay? Again, I want to know px. I want to know this guy, which is going to be py. With that, I can solve for the momentum that's missing here. So, what is that stuff? I hope this is correct. I'm not going to put all this in my calculator, but px would be that minus that, and I got negative 0.157. You got 0.57? That's what I wanted. That's what I should have said. That's what I got. Okay, does the direction look reasonable at least? Right? Does the direction look reasonable? Yeah, it does. I'll answer my own question. Okay? Better be negative because it's going left, that fragment. Okay, so same thing with y. Let's write it. Py before is py after. All the momentum before in the y direction was 0. After, what do I got? I've got this thing, which is 0.212 times 9, but the vertical component, which is sine 60. Do I want to make this one negative? No, because that's going up. I'm taking up as positive for y. Okay, and again, you don't have to. You just have to be consistent. What else do I got for y? Anything from this guy? No. That's the only other one I got. Let's call it py. And what do I know about py? It is negative. So let's make it negative. Okay, now if I solve that for py, that will come out as positive, but I know the direction. It's down. If I put plus py, it would just come out as a negative. So I don't know how you want to think about that, but if I'm consistent with this, I'm going to put a minus here, and I know the answer is down 60. Okay, so py then is that times that times that. I got 1.65. Okay, but down in that direction. So if you want to now put that as a negative, be my guest. Okay, I want to add that and add that. So even see here, like I know the direction, so I'm not going to put a minus, right? I know it's going left. I know this is down, so I'm not going to put a direction. And when I square it, it's all positive anyway. So what is the momentum of the third piece? Square that, take the square root of it. Should be a number that looks like it makes sense. Double check my math. What's the units for momentum? Kilogram meters per second, mass times velocity, yeah. Is that the answer? No, because that is a vector, right? So what's the direction? Inverse tangent of 1.65 over 1.57 at 46 degrees southward of due west. Okay? So nothing really too new, it's just now things aren't coming together and sticking. They were stuck and they're coming apart. But what's another way to solve this? The easier way. Yeah, that's right. Okay, so again, let's redraw this thing without the pieces. Let's just put in numbers. 0.212, that's kilograms, times 9 went that way. This way went 0.168. I hate looking like that. Let me put brackets. 10. It is 15. That's weird. I didn't even write it down right in my notes. And the unknown, which is, I don't know. Yeah, call it B. So, how do I do that? How do I join these head to tail? Okay, well, let's take this guy. Oh, and I forgot an angle. That's 60 degrees. Okay, so what is 0.212? Well, let's just write it. 212 times 9. Let's add this one up there. 0.168 times 15. Now, you remember yesterday? You maybe got a question where, what is the third component I want to add so this thing doesn't move, so it becomes in equilibrium? These two come together, and I want this guy to go like that so that it doesn't move. See, right here, the resultant would be this, but I don't want a resultant. I want this thing to be in equilibrium, so I'm going to take the minus of that vector. So what you see is everything here is added head to tail, isn't it? It's like going around in a circle. That means equilibrium. There is no resultant. This is balanced. Right? Because the resultant of those two would be something like that, and that's what I want to add to it. So they're all head to tail. And yeah, there's other ways I can do this. I could put this one down here. Instead, add it head to tail, put it like that, this guy, and then this guy would be like that. It's the same triangle, doesn't matter. All right, so that's what I got. This is what I'm trying to find out. So all I need to know, using cosine law, is side, angle, side. It's always the angle in between the two sides. I need to know what that angle is. What is that angle? Yeah. Because this thing's parallel to this, isn't it? So, parallel lines, there's a transversal. This angle is equal to that angle. Well, that's a little nicer. So p squared is, well, I should write that down like that, but let's just do it like this. That squared plus that squared minus 2 times that times the angle in between them. I'm just lazy. Let's call that A, let's call that B. Okay, so none of you will do that, of course. You will do this. So I should have done this.
Is it in degrees?
Sorry?
Is it in degrees?
Probably not. Thank you. 168 times 15. That is 2.52. Guys done already? That is 1.908. So that squared plus that squared minus 2 times that times that times cosine 60 is p squared. Take the square root of that. With any luck, I get the same thing. It's off. How come? Instead of 2.52. Okay, well, guess what? P is the same thing. Yeah. Plugged it in wrong. Okay, so that's all fine and dandy, but what do I do about the angle of this guy? Yeah, sine law. Okay, that's 2.28. Now I have to get an angle in the triangle for this. That was the angle I used before, wasn't it? Right? So that's the angle I'm going to do again. I mean, I could get that angle and then work it out or whatever, but let's do that guy. So sine a theta over 1.908 is the sine of the only other angle I know over 2.28. So the inverse sine of sine 60 times 1.908 divided by 2.28 is 46.4 degrees. South or westy. Okay? I don't know what way you want to do it, but if it were me, I would do that. As long as sometimes this angle in between the two things is pretty tough to figure out, and it might be easy to make a mistake. Okay? But you might guess, I don't know, whatever way you want to do it. So that's it for this sheet. That's it for momentum. We should be finished that